Welcome to class ICT STPM Semester 1. Our topic today, the 5 domains of computing and ICT.
Welcome to this explainer. Today, we're decoding the absolute alphabet soup of modern technology. We hear terms like IT, computer science, and data science constantly, right? But how do they actually fit together? Let's map out the digital ecosystem that powers our world today. Not as a boring list of subjects, but as a living, breathing digital city. Okay, so here's our roadmap for today. We'll explore this metropolis in 6 steps: decoding the digital world, building the software, managing the infrastructure, securing the system, data and artificial intelligence, and lastly, the connected future. Let's jump right into Section 1, Decoding the Digital World, the Foundations of Computing. We'll start our tour right here at the bedrock. But before we lay a single brick, we've got to answer a question that confuses, well, almost everyone from college freshmen to corporate executives. What is the actual practical difference between computer science and information technology? People use these terms interchangeably all the time, but they play entirely different roles in our digital city. Here's the best way to look at it. Computer science, that is your architecture. It's the theoretical design, the complex algorithms, the underlying physics of how systems work. Information technology, on the other hand, is the maintenance and the utilities. It's the practical management of that technology once it's built to ensure we can actually store, retrieve, and send information. Simply put, one builds the skyscraper, the other makes sure the elevators run and the lights stay on. Moving right along to Section 2, Building the Software, Architecture, and Construction. Let's see how this city actually gets built. As we just mentioned, computer science lays the groundwork, and it goes way beyond just writing lines of code. It's the relentless pursuit of efficiency through algorithms and data structures. It's where the actual blueprints are drawn for artificial intelligence and how we design human-computer interaction so we can, actually use these brilliant systems without getting frustrated. So once that architectural foundation is set, the software engineering construction crew steps in. They built things iteratively using agile methodologies. They utilize DevOps, which essentially acts as a wrecking ball to those old, slow corporate silos between developers and operations teams. And crucially, they run rigorous testing and quality assurance to make absolutely sure the digital roof doesn't cave in under pressure. Section 3, Managing the Infrastructure, Utilities, and Roads. Once the software is built, how do we keep the data flowing? This is where information technology takes center stage as the city's critical utilities. It covers network administration and providing that essential technical support that keeps the whole infrastructure humming. If a server goes down or a network bottlenecks, these are the folks who jump in to get the city moving again. But remember, technology has to serve a practical purpose. That is exactly where information systems come in. They are the bridge applying tech tools directly to business strategy. We're talking massive database management, huge enterprise systems like a company's CRM or ERP software, and business intelligence that turns all that raw noise into actionable insights for major strategic moves. And connecting all these diverse digital buildings? The roads, networking, and telecommunications. This field ensures that your voice, video, and data flow seamlessly. Today, those roads are increasingly invisible, relying heavily on high-speed wireless mobile computing, utilizing technologies like 5G and Wi-Fi to keep the entire ecosystem constantly connected. Now, here is a massive shift in how our city operates today: cloud computing. Instead of building localized power plants, companies just rent computing services over the internet. They can rent raw virtual infrastructure with IaaS, they can rent development platforms with PaaS, or they can rent fully functional applications delivered directly over the web with SaaS. It's entirely on demand and incredibly efficient. Section 4, Securing the System, the Digital Police Force. So what exactly happens when a threat tries to break into our beautiful city? Enter cybersecurity. This is our dedicated defense system protecting valuable information assets from bad actors. And the stakes here are astronomically high. Threats are constant, ranging from direct hacking attempts and malicious malware to massive data breaches that cost millions of dollars and severely compromise our personal privacy. This defense involves information security to protect assets, and cryptography, which uses some really complex math to scramble data so intercepted messages remain completely unreadable. But perhaps the coolest tactic is ethical hacking. Organizations actively employ good guy hackers to perform penetration testing, intentionally trying to break into their own systems to fix vulnerabilities before the real bad guys exploit them. Section 5. Data and Artificial Intelligence, the City Planners. Let's take a look at the domains that are actively predicting our future. Every single second, we generate a chaotic, massive volume of unstructured noise. We call that big data. Data science is the discipline that steps in to extract actual statistical knowledge from that chaos, using advanced computational and machine learning techniques to visualize trends that humans can actually wrap their heads around. And from this massive well of data, artificial intelligence creates intelligent systems capable of real reasoning and decision-making. You have machine learning algorithms that allow systems to learn from experience without explicit programming, natural language processing, which enables machines to understand human speech, and deep learning, which utilizes complex neural networks, literally inspired by the human brain, to solve incredibly complicated problems like real-time image recognition. Finally, Section 6, the connected future, expanding the city. Let's launch right into the frontier. We're no longer just staring at flat screens. Virtual reality completely immerses us into simulated, entirely virtual environments. Augmented reality takes a slightly different approach, enhancing the real world by overlaying digital information right on top of it, like visualizing exactly how a piece of furniture looks in your living room before you even buy it. Meanwhile, the physical and digital worlds are merging through the Internet of Things, or IoT. This is the phenomenon of turning everyday, formerly dumb, physical objects into active data communicators by embedding them with tiny sensors and internet connectivity. What's absolutely fascinating here is how the technology scales. It starts small with your home's smart thermostat, sure, but it scales all the way up to massive industrial IoT, where manufacturing plants use sensors to predict machine failures before they even happen. And to make it all work instantly, we use edge computing, processing the data right there at the source, at the edge of the network, for lightning-fast, real-time responses. Ultimately, all these interwoven domains, from the theoretical architecture of computer science all the way to the interconnected devices of IoT, are exactly what drive modern innovation. They improve efficiency and shape the very way we live, work, and play, impacting literally every single industry in our digital world, from healthcare and finance to education and entertainment. Which leaves us with a fascinating final thought for this explainer. As we watch these distinct digital neighborhoods, AI, IoT, cloud computing, continue to blur, merge, and evolve at a breakneck pace, what entirely new domain of computing will our world need to invent next? Something to think about. Thanks for exploring the digital ecosystem with me.